Welcome to this presentation of FA³ST, the Fraunhofer Advanced Asset Administration Shell tools for digital twins. The Asset Administration Shell is a digital twin specification with a focus on industrial production. It is developed and maintained by the Platform Industry 4.0 and published as open access. Digital twins follow a life cycle, starting with identifying the need for a digital twin, modeling it, and developing an executable digital representation. After the digital twin has been deployed, it can be shared with and used by others. In the validation phase, the need for new digital twins can be identified or existing digital twins may need to be adjusted. FA³ST aims to provide a set of tools that support users and developers in any phase of the digital twin lifecycle. In this presentation, we will talk about the FA³ST service, which focuses on the development phase and enables creating executable digital twins. From a non-technical view, the FA³ST service is a piece of software that we feed with an AAS model and a configuration file to create an executable digital twin that can be communicated with using an AAS-compliant digital twin API based on different communication protocols such as HTTP or OPC UA. Additionally, the FA훼ST service allows connecting the digital twin to the underlying physical asset using arbitrary communication protocols. From a technical view, the FA훼ST service consists of two central components, AAS model and core, and a set of interfaces which makes the software easily extendable. FA훼ST service comes with some predefined implementations of these interfaces. For example, an HTTP as well as an OPC UA implementation of the endpoint interface, as well as implementations of the asset connection interface for MQTT and OPC UA. Let's see the FA훼ST service in action. First, we define a simple AAS model containing one AAS called machine AAS, which contains a single submodel called status, which again contains a property temperature of type double. We configure the FA훼ST service to provide both an HTTP and an OPC UA endpoint. For persistence and message bus, we use the default implementations. As a first step, we will start our digital twin and read and write the temperature value via HTTP and OPC UA. Accessing the corresponding URL in the browser, we can see the current temperature value. With the help of an HTTP client, we can now update that value. Check by refreshing in the browser that this was successful. Using an OPC client, we can do the same for OPC UA. Browse the service structure to find the temperature property and subscribe to its value. We can now update the value via OPC UA. And verify again via HTTP that the value was updated. So far we have a digital twin that we can read from and write to. However, an essential part of a digital twin is that it is synchronized with the actual asset it represents. By updating our configuration and specifying an MQTT asset connection, we can connect the digital twin to the MQTT server of our machine, providing live temperature readings. When starting the digital twin, we can verify that the digital twin is updating with live data via hitting refresh in our browser or by subscribing to the temperature value via OPC UA. FA훼ST service is implemented using Java, available as open source and easily extendable. You can download the code from GitHub or use the pre-built Docker containers available at Docker Hub. If you have further questions, feel free to contact us at fast@iosb.fraunhofer.de or for technical questions, create a GitHub issue.